In this video from Notes 6.2, we're going to explore cofunctions of complementary angles. So a cofunction is sine and cosine, or tangent and cotangent, or secant and cosecant. Those are what a cofunction is. So at the upper right corner of the page, I have a little right triangle. And I've labeled the vertices A, B, and C. And what we're going to do is we're going to look at an acute angle, which I've labeled theta, which is by angle A. So if that angle is theta, then we want to determine the measure of the other acute angle, which would be angle C in this case. So those two angles are complementary because the sum of the measures of the angles in a triangle measure 180. So this angle would be 90 degrees minus theta, or if we're in radians, it would be pi over 2 minus theta in radians. The next thing that we're going to do is we're going to label the side lengths of the triangle relative to angle A, or angle theta. So if I do that, the side opposite the right angle is the hypotenuse. The side opposite the given angle, so I'm going to go across the triangle from angle theta, and I'm going to label that as the opposite side, and the third side is the adjacent side. Now, the next thing we're going to do is we're going to think about sine of theta. So remember, sine of theta is the length of the opposite side over the length of the hypotenuse. So here, the opposite side, right, I'm just going to call that, I need to do one more thing, sorry, before we do that. We are going to label the side lengths, and this is a typical way to label side lengths of triangles. We label the side lengths using the same letter as the vertex that's opposite it. So if we have a vertex capital A, so vertices normally have capital letters, capital A, the side opposite has a length of little a. And if we have vertex capital B, the side opposite that has side length lowercase b, and the side opposite vertex C, this is a capital C, will have side length lowercase c. And that's typical for triangle problems, right? Triangle problems and others that you'll solve next year. So the length of the opposite side then here is A, and the length of the hypotenuse is B. Now we're going to take a look at cosine of 90 degrees minus theta. So I'm going to have cosine of 90 degrees minus theta. So 90 degrees minus theta, remember, is this other angle. That's angle C. So relative to angle C, I'm going to label the side lengths as well. So relative to side length C, I'll do that in red. And angle C, the hypotenuse is the same, but the opposite and the adjacent switch. So this is relative to angle 90 degrees minus theta. And this one, the red one, is relative to the same angle, angle 90 degrees. Oh, I have to move that down a little bit. So let me move it down. I didn't have enough room. Relative to angle 90 degrees minus theta. That's the red one. Okay, so cosine of 90 degrees minus theta is going to be the length of the adjacent side relative to this angle. So that is A. And the opposite side, the hypotenuse is still B. So this is equal to A over B. And you'll notice that these two values are the same. And notice that we have not specified the angle. So it will always be the case that sine of theta, so we've shown that sine of theta is equal to cosine of 90 degrees minus theta. And this works for any pair of complementary angles and their cofunctions. And we saw this on the previous page, right? The sine of 30 degrees was 1/2, which is equal to the cosine of 60 degrees. This occurs because 30 degrees and 60 degrees are complementary angles. So we can actually get a set of identities, equations that are true for every angle. So if theta is an acute angle, we can say, based on this derivation that we did, that sine of 90 degrees minus theta is going to be the cosine of the complementary angle to 90 degrees minus theta, which is theta. Likewise, we can say that cosine of 90 degrees minus theta is equal to the sine of the complementary angle. So that's sine of theta. And actually, the name cosine comes from this relationship. So cosine comes from the fact, comes from the sine of the complementary angle. That's why the function is called cosine. Right, so that's what we're talking about here. Cosine is the sine of the complementary angle. Likewise, we can do other pairs of cofunctions. So cofunctions tangent and cotangent. So tangent of 90 degrees minus theta is cotangent of the complementary angle, which is theta. So we can say the cotangent is the tangent of the complementary angle. So cotangent of 90 degrees minus theta here will be tangent theta. And secant goes with cosecant. Those are the cofunctions. So secant of 90 minus theta is cosecant theta. So we can say that cosecant is secant of the complementary angle. That's where the name comes from. And cosecant of 90 degrees minus theta will be the secant of the complementary angle, which is theta. Okay, then I'm just going to read this note down here. So far, we learned how to find trig ratios given the lengths of two sides of a right triangle. The Pythagorean theorem gives us the third side, or for special angles using the special right triangles, 45, 45, 90, and 30, 60, 90 triangles, we were able to derive some trig ratios. But if theta isn't one of these special angles, then how do we find the trig ratios? And for that, we need to use our calculators. And if you watch the next video of example 4, I'll walk you through how you find that.